You know, coffee is a staple prop, and coffee shops, coffee houses, cafes, and diners are classic scenes in American movies and TV shows.
This is, excuse me, a damn fine cup of coffee.
So today we're going to be looking at one of our favorite TV movie show clips involving coffee, which is the coffee scene from Breaking Bad. And we're going to look and see if what they're doing aligns with what we've researched in our lab. I'm Maya Fetzer. I'm a senior chemical engineering and Spanish major, and I have the privilege of being a part of Bucknell's Coffee Research Lab.
And I'm Kat Wakabayashi. I'm a professor of chemical engineering, and I am one of several coffee researchers on campus. As chemical engineers, we get to place ourselves in this scene and talk about the actual science and engineering that goes behind it. Even the fact that they are designing the best cup of coffee is something that we do in our classes for different kinds of products.
Yeah, so let's go take a look.
First, curious about this.
Wouldn't it be cool to have one of those in our lab?
It looks pretty elaborate. It has a lot of glassware. It looks like it's hard to clean afterwards.
In my opinion, it's all about the quinic acid level.
So they're talking about quinic acids. Do you think those are important, Waka?
Actually, quinic acid is a component of coffee, but what actually matters more for the quality, the kind of the brightness and acidity of coffee is the caffeolic quinic acid, which is actually part of the CGAs, the chlorogenic acids. We have many, many isomers of that. And those are something that we can actually measure in our lab.
Yeah, we have a research project that works on measuring CGAs using voltammetry, which is a kind of electric measuring. So hopefully we can even use AI in the future to predict what kind of quality of coffee is based on those CGAs that Walter's talking about in this scene.
But if you overboil to get there, you're going to leach your tannins, bitterness, yuck. So I pull a mild vacuum that way, and I can keep the temperature no higher than 92 C.
So 92 C. Don't you think that's a little cold for coffee?
Actually, that's okay for dark roasted beans. I think that's an optimum temperature so that only the good part, the sweetness of the coffee beans come out. Some of the other coffee beans, like the lighter roasted beans, I think needs to go up higher at 96, 98 degrees C. But I think this is reasonable. Do you know why Gale pulled vacuum to make his coffee?
Yeah, we learned about that in Keg 200 with Professor Meinhardt, that changing pressure can change the boiling point of a liquid.
Right, so by pulling vacuum, you lower the boiling point of water, which is that 92 degrees that they were talking about. So that makes sense.
None of those will steam though. That part gets me every time.
That hissing that you've heard doesn't seem realistic there.
Would you be worried if our lab equipment was hissing like that?
Maybe it's under high pressure. Oh man.
Some high pressure coffee brewing. Yeah.
Sumatran beans.
Well, the choice of Sumatra beans is pretty cool. I think it's a pretty well-established, full-bodied, kind of complex kind of beans, and it kind of matches the character of Walter.
Yeah, we've had Sumatra even for our dinner seminar class here, where people get to try like Sumatra, Brazil, Guatemala.
And I also have to give credit to the grind.
So here they're talking about grind size. I remember my first research project in this group when I was a sophomore was working on particle size. So I really got the experience to sit and work and learn all on my own, and it grew my ability both as a researcher and just as someone learning a lot about science.
Yeah, and the results are pretty interesting, right? A wide range of particle size distribution, even for a fine grind or a coarse grind. In this scene though, I'm pretty sure that they used coarse grind, like that coarse sea salt kind of size, because they actually have a pretty long residence time in that tubular reactor there.
We just learned about residence time in my kinetics class, so it's pretty cool how coffee and industrial reactors can be modeled the same way.
Yeah. So all in all, I think it was a well-curated TV show clip, and it was really fun to connect our knowledge and our chemical engineering backgrounds to this TV show.
So we can get one of those in the lab, right?
Ask your department chair.